Hi guys, welcome to part 6 of our series of videos on the codec model. Sorry, on the org codec. So we are more or less done with all the work. This is kind of a closing video really. First thing we need to check, actually, we had a problem as we are talking. I just want to double check this. Let's have a look at our C dashboard. Okay, we tried to solve a problem and it seems like we've increased the problem. Okay, so it seems to be failing to run the frozen tests, which is fine. We probably just made a mistake when we were doing the checkout for frozen. Let's have a quick look. Well, this is not quite what we're going to look into, but first priority is always to get the build green. So if we have a quick look at update scripts, perhaps. So we're doing a download file here. Let's make sure we didn't do anything silly here. Here we go. We definitely did something. Oh no, sorry, wrong place. Frozen. There we go. So let's just have a quick look at what we think the download location is, which hopefully will be available in the Windows build. If we just have a quick look at the log, and around here somewhere. Right, so this does not look terribly healthy. Right, so what we would expected to have seen here is we would have expected to have seen the download of the So the frozen input location is the frozen project. As I mentioned, this is just an archive of Dogen with all the models that we've just decommissioned. But interestingly enough, we don't seem to have an equivalent location. So there's an input. Right, so I think we just we copied and pasted, but just not enough. So let's just replace okay, that makes sense. And now let's have a look at what the frozen. Right, okay, so we are basically making use of the variables such as the downloads location, and they installed the directory, and there was no such thing. Okay, so that explains why frozen failed to install. And then let's just double check. What else could it be that we're doing wrong? Because there's a lot of failures, not just 47 as we'd expect to see. So let's see. Right, so we seem to have borked. Yeah, we seem to have somehow borked the tests for the reference implementation as well. So, in fact, to be on the safe side, to avoid this problem in the future, let's just be sensible here and have two different areas. So if I just and in fact we already had that, we just didn't follow the pattern. So I wonder if we broke something here by mistake. Let's have a very careful look at this. So this is the download, this is the path in GitHub, this is the download path, that's the install directory, the reference models directory, which would be some kind of, there we are. So top level directory. Okay, so that looks fine. There we go away. It did but what's going on? Okay, sorry, to just jump to the location here. That looks fine. That looks fine. Looks fine as well. So let's have a look again at that. Just make sure that there's nothing else is broken on those downloads. But you can see there is something not quite right. So we have a download location which looks good, but then option value is not specified. File name. I wonder if we inadvertently reset some variable. Set location. It's peculiar. So the download file seems to have worked. These two paths here look correct, but some variable is evaluating to empty, I should think. Right, so well, we don't think it's the download file that's causing the problem, so just be very careful about this. So that looks fine. That probably will also look fine. We see the URL and the downloads correctly. Let's just have a look at how this was before we started messing around. Before frozen. And in fact, to be honest, there's always the easy way out, which is to say, let's just start off with that. That looks sensible. And then we know for sure this is working, so now let's do the proper copy and paste job, which is to copy the block and then replace. Now that I think is a more sensible approach really, because everything else should be exactly as is. So and now as you can see here, the only thing that changed was the frozen bit. Now that is a bit worrying because we seem to be getting an error elsewhere. Problem seems to be coming from set locations, so that's definitely not null. Okay, so I think I'm going to gamble a bit here, but I think that looks alright. So let's just fix paths to frozen in downloads. Not entirely clear why it's failing for both frozen and the other guy, but we'll just leave it at that, just to get ourselves going again. So what we're going to do in this video then is we're going to make use of our org model. This is kind of sort of the bridge between the previous work and the next bit of work. We have done, as I explained, we've already done most of the work required to support org mode. What we're going to do now is make use of it. So we are going to create a new model. Well, actually, I thought we were going to create a new model, but in reality, we probably don't need a new model. We started off by considering the creation of a model for PlantUML, and as you can see here, we started to work on that model, but I don't actually think we need it. And the reason why is, if we just go up to our UML area, so here's an example here of a PlantUML diagram, just to sort of sample bits. And I think, actually, we're going to give it a good go at trying to create this on the fly. I think this probably would work. Well, we'll give it a good go, and if that doesn't work, then we worry about that. So instead of worrying about creating a new model, we'll just delete that model we created, and we will instead focus on our Codec model. And in the Codec model, let's add a new transform. This guy here will probably be sufficient. So as you can see here, this is what we're going to be doing in the future. Then now problems start immediately because you can't really use a custom ID or the die-based custom ID. So what we'll do is we'll just insert a UID. I'm sure we had support for that. I thought we had some kind of UID mode. Let's have a quick look at the packages. It's available, we haven't installed it. So let's just okay, annoyingly we don't. Let's have a look at the functions provided by okay, did the installation fail perhaps? No. What function? Oh, UID create. Oh, still, you would have thought you would get some kind of help. I wonder if I have to actually physically Right, this was not the most useful of modes. Let's try the other one. Some of these modes are actually only for a Lisp, so not really designed for you to use on the fly. Okay, much better. Right, so there's the UID. And let's give it a nice name. Oops, let's give it a nice name of PlantUML artifact. So model to PlantUML artifact transform. Something like this, right? We have a model and we're going to convert it to a PlantUML artifact. So it's the other end of the generation. So if I just go here and I say please generate everything, it should have created the transform, and as you can see it did. Okay, so it's just as usual, just commit the transform without any changes. So Codec generate UML model to PlantUML transform. Let's also add to add all these things here, and then models of PlantUML model. Don't think we're going to need that. Right, now then, this is all looking good. And if we just take the PlantUML transform, I suspect we could probably get away with something like a org mode transform. So model to org transform, I think this is probably a copy and paste of this guy here. Do a little bit of tidy up here. I mean, it's not going to be identical because, of course, if you remember, we have an org model rather than conversion to a string, so we need to get rid of the org stuff here, but other than that. So, oh wow. We've updated our artifacts today, our snippets. Brief. Generates, okay, I'm not sure if I'm a big fan of all of these guys here. I might have to update my snippets. So generates, transforms codec model into an artifact in PlantUML syntax. Right, so something like this. And then what we'll do is we're going to first try to not worry about any containment or anything like that. We're just going to create the simplest possible model, and we will see what happens. Probably just need something like attribute and what else we need? Let's think about the functions we're going to need. Probably going to need a stream, so output stream, I guess. Not going to need a map or an optional file system, I guess. Element, attribute, model, artifact, and context. Okay, that's sounding quite good. Now we're going to use a few functions. So, for example, we could have something like string tagged values to color. And this is going to basically be our inspection on the tagged values to obtain a color. We will also need something like, and these are probably going to be separate functions. Void is all static, of course. To stream, whatever you're going to call that. And this will be something like a stream by reference. And then we, for the first one, we can just have the elements. And for the second one, we could just have the attribute. Right, and I guess for good measure, we probably need some kind of way to do packages. Yeah, so perhaps something like static string tagged values to, I mean, we shouldn't really need the tagged values too, but so tagged values 2, and this guy is gonna basically find well, we need to know what's the stereotype, I guess. Right, so this is going to extract the stereotype out of the tagged values. In fact, we need to extract a whole load of things, if I'm honest. So let's just say private. Sorry, private. I'm thinking while typing at the same time, which is never a good idea. So struct. I don't know what to call this, but we're going to need string parent, string so we need the parents, we need the stereotype, What else could we need? Parent stereotype. I don't know, let's call these properties for now, so we have a good name. So we could have something such as extract properties, I guess. You supply the tagged values and we will give you the properties. That sounds vaguely sensible. And then we could have stereo type to color, where you give us a const string of stereotypes and we shall return you a color. Brain is not functioning totally today. So let's see that if we just extract the parents, the stereotype, I think that would at least get us going. The attributes, we will just dump them directly to stream. Let's have a look again at what we think the output should look like. So these are kind of relationships, I guess. Abstract interface, packages, so we can just monitor for elements of fallback type of module. That's about it, I think. Okay. I think that's probably enough. Let's not get too ahead of ourselves. It's always good to do a bit of the work and then see what comes out of it, really. Right, we don't really need the struct. Something like this. So that's gonna have a stream. Yeah, that's not too bad, really. And we could then start to say things such as, well, first before anything else, let's just get the traditional infrastructure that we always need. I mean, it's not going to be like a super spectacular sort of thing. We just, and so for a bit of context, right, the problem we have at the moment is because we got rid of dia, we have no way to visualize it, the class structure. And so we just need some very basic support that enables us to just have an idea of what the diagram looks like. Don't really expect for this first pass to have a spectacular representation. We don't even know really if PlantUML can cope with all the wonderful variety of stuff we got in Dogen. It looks like it from the examples, but guess you just have to do it and see what happens. So I'm just going to try it out. Probably needs a stream. And finally, we will just grab the bits that we need. Let's also obtain the IO for the model. Just get to a point where this code compiles, really. I think that's quite close. Now, if I copy all of these, and if we just say something as simple as sudo string stream os, then do something to the stream, then finally do a const out2s os.str. Right, so that's sufficient to get us going. And now we just need these guys here to do their thing. I always like to just start with sort of compilable code, so a bit annoyingly what we need to do is to get these guys here. I quite figured out how to comment C style in Emacs. Quite useful. Right, and then presumably we just need something like for const out2 by reference e m.elements to stream os e. That will do all the elements, and then well, actually we probably let's just get rid of these guys. And this guy as well. Okay, so the code is compilable now, which is what we wanted. Now let's just do some basic stuff. So this guy here is probably quite trivial. For const auto by reference attr in e dot attributes to attribute to stream attr. Okay, that was simple enough. And okay, I think that should give us a beginning. So let's then start to output something that outputs something. If you see my my clever pun, don't particularly need it to be super spectacular. We just want where were you? UML 8. So I'm not even going to bother with constants just yet. So this guy is just going to output a start and an end to a UML diagram. Sounds simple enough. Run all tests, should pass. Oh, as always, nothing quite turns out the way you expect. Forgot that I offered the artifact. Right, so this does something. Well, compiles. And then what we're going to do then is we're going to look at model to artifact chain, perhaps. In this chain we're just going to register a new extension. Is this guy here. And we just need to grab the transform. And then just detect PlantUML codec name and just run the transform. Shame it doesn't detect that we already have part of a string filled in. Right, so now then, if I was a good citizen, I would actually now create some tests, but being lazy as I am, I'm not going to bother with that just yet. middle of my shell. And in my shell, I will look for projects models, and in the models I'll have some org models, and then we just choose the simplest possible model. Let's take the Dogen binary, and if I do something such as Dogen.org will be a good example. So if I just try to convert with the source and a destination, wrong key. Okay, no transforms are available for Codec. PlantUML. Okay, no problems. So interesting. I'm slightly confused. Where were we? 6, I think. No, 6. Yeah. One thing that perhaps could explain this is we may have forgotten to have recompiled the code generator. Okay, fine. Okay, so we just forgot to compile the code generator. Now what we're going to do is we're just going to do something interesting here. We will just go up to the models directory, and around here we'd have a PlantUML diagram. Okay, so here's our diagram as it stands. Now then, start by doing something really simple. In fact, we probably need 2 diagrams here. In fact, what I'm going... Oh, unfortunately, you can only see one monitor. We could use 2 monitors for this, but only one is recorded, so we'll have to make do with 1 monitor. Right, so what we would like to see first is we need something like the class name coming out. So perhaps class, and then perhaps an end line. Okay, so this should give us now ideally we want the shell to be around here somewhere, really. Let's think about this. In fact, I think we'll have a problem as well. The mode, PML mode, PlantUML mode is not the best in terms of managing new buffers, so of course we must remember to compile. I think what we're going to do is we're going to, every time we run compilation, we'll just add a new line here. So if we just cd over to projects, Dogen.models, org, and okay. I mean, we don't really care. Okay, good. So we're supposed to cd into here. Not quite sure what's the easiest way to tell the compiler to always do this regardless. Well, we're going to go with and then what we need to do is to make sure that there's always a change. Okay, with the change then enforces compilation. It seems to do something. Let's have a look at UML buffer. Okay, cool. Righty, so as you can see we did something. Probably worthwhile having another end line here, just for a laugh. Then let's say that the class has a name, which is E, not name, and we're going to go for the qualified name. See what that gives us. Okay, that doesn't look too bad. Now let's try to generate that. Okay, that's not bad actually. Not sure why the classes. Okay, so what happened is, seems like we found a bug. And the bug is if you're coming in from org, qualified names are not actually doing a sensible thing. We need to fix this bug. So so when you're reading the org model, we are probably just concatenating the qualified name. Here we are. So let's basically say something like so if qualified parent dot empty, this is a simple case. Qualified is just going to be identical to the simple. Else, well, there's something to qualify, so let's just qualify this properly. Right, now then, this is now going to solve this silly issue of having the colons there. And hopefully that will give us a set of classes. So it's not too bad. We can see a few classes there. They all look vaguely sensible. So the next thing we'd like to see in these classes is we'd like to say, well, if you have a stereotype, please give it to us. So let's try to extract these properties then. So what we're going to do, I mean, there's many ways we could do this. I mean, I could actually, if I wanted to, I could use the configuration subsystem, but we are going to do it the lazy way, I think, because I think this is going to make life easier if we do it the lazy way. So what we'll do is we'll just take one of these guys. Let's take something that has a few things. So entities will be a good example. And in entities, what has parents? I don't think anything has parents in this model. Let's try something like the logic model. Still need to get used to dia. Right, so anything with a parent. Okay, abstract feature is not one of them. Right, here we are. So this guy's got a parent. And this guy's got some stereotypes. Okay, now then, we could just very simply say, well, this is my parent key. this is my stereotypes key. And we just look for these keys. And what we're going to now do is something as simple as this. For const auto by reference TV in TVs, if TV.key tag, so let's call these tags then. So if the tag is the parent, please do r.parents equal to tv.value. Else, if type, if the tag tv.tag is equal to the stereotypes tag, r.stereotype. Well, to be honest, we should really call these stereotypes because they're going to be multiple. Is equal to dtv.value. And that grabs 2 bits of information. And now we could say something like const auto stereotypes equal to extract properties on e.tagged values. Okay, so if there's any sorry, not stereotypes, but properties really. Let's call this props, a bit long. So, and then what we want to do, we want to know if the stereotypes are filled in. If they are, we need to populate them. One thing we don't really know is how well does PlantUML cope with multiple stereotypes, but nonetheless, we'll just go with that. So now then, we have a name. Before we go any further, what we should probably do is something like output the name, because we know for sure we'll have a name. Then do something such as if props.stereotypes.empty. In other words, if they're not, then we want to output stereotypes, but not just output them. We need to put the usual UML notation for stereotypes. And then finally, whatever happens, we need to then output the close brackets. And then if we have a quick look at the notation for colors, you can see the colors just go just before. So we could probably do something like let's see, how do we convert these to colors? So we have a table from our palette, which is this guy here. We could probably take this table. I'm going to need it in 2 different forms, so I'll paste it in 2 different places. Just say this guy could wait a second. And for these guys, what we want to do is bit of a macro, I guess. So const string so if we just take this guy and put all of the okay, that didn't work as expected. Well, actually, there's one thing we can do here very quickly. We don't really care about the colors, so let's just get rid of the colors first and foremost. So if we do another macro, end of line, go back, find that, delete, beginning of line. Okay, so let's first just get rid of all the colors. And then let's get rid of the start of line. Okay, so now that gives us something more similar to the end string. Now let's create another macro that says const stud string and then whatever the text, and then if we so what can we not? Oh, we can. Okay, good. And then okay, something like this. So that's gonna. Oops, one slight problem is with the long lines. One has to be slightly careful when making a macro. Let's just rewind a little bit. Okay, so because it's a long line, just make sure we're not gonna trample over the next line. Right, so that's gonna give us almost everything we want. And then finally we could basically say, well, every time you find MASD blah de blah, let's just replace that with an underscore. And I guess that leaves us with the remaining colon. So quickest way to do that is probably to say, well, let's create a macro, look for the end, look for the brackets, look for a space, replace with that. Oh, that was going quite well. Let's try again. So go to the end, look for a bracket, look for a space, replace. Oh, okay, there's something wrong with the replacing, I think. Not quite sure what. I think there was something. Okay, we're not in query replacement for some reason. Okay, let's try again. Sometimes it takes about 10 goes. Query replacing region. Yeah, there's definitely something. For whatever reason, when you're doing a query replacing region inside of the macro, Emacs is not very happy. Alright, fine. I'm not sure why that's the case, but let's not waste too much time on this. We probably have there is no obvious way to replace these strings. Well, instead of wasting more time, we will just do it the good old-fashioned way. Sometimes that's the best way. You only have a couple, it's actually about the same as doing it cleverly. Right, so you should be getting the gist of what we're trying to achieve here. Not very nice, but we got ourselves some basic constants for the stereotypes. Some of them are a bit long, so let's try to make them fit. Right, now then. double check that we... I think this code looks roughly good. This is commented out, so okay, let's just try to get this to compile first. Not sure why this chap is moaning so much. I think it's just LSP. Okay, right, now then, we have a whole load of constants here, and we need the boost algorithm. I don't know why my includes keep changing. I'm wrong. I think there is just an algorithm and a string. So, now then, let's see what we do with this, guys. We want to do something like, if you contain this, then return that. Not sure if I'm going to bother with the colors, make constants with those. Let's see what we can do. So in this particular case, we could just say, let's get rid of these guys. Let's get rid of that. And then let's say something like, probably needs a very simple function here. Let's imagine the simplest possible function. Something like given this, we return so this is the stereotype. Well, we could just access these stereotypes, and we could say if boost contains either one way or the other. I never quite remember which way it goes. Let's get some help for the function. Not being particularly helpful. So that was a little bit quick. Something about the input and the test. So that's the case. Oh, of course we need to return a color. So right, something like this. So if you have a stereotype, return color. There's many ways of doing this better, but we just need a quick hack. Now then, what we need to now do is to say something like, oh, let's see why this guy is not happy. Right, so let's just get rid of those semicolons. I think they're interfering with our indentation. So right, so this should now give us some kind of basic, very simple way to convert the color. Still not very happy with our, just need something like this. Right, something like an empty string. We really should have a constant for empty strings. There should be a better way of doing this in C++. We need to look for. For now, we're just defining empty strings all over the place. Well, so very, very simple function, and then we could say well, let's just stick to the English spelling, shall we? So if I send the stereotypes, so we're not going to have a color. Oh, actually, one thing we probably should say is if there is nothing. Oh, we have 2 here. So if there is no color, we should probably default to a default color. So instead of empty, we'll call that default color. So if there is no color, just use this default color. Which, to be fair, part of me wonders if we should just use the default color for PlantUML, but well, there you are. Now, so this guy is going to attempt to do, well, so we need to make sure we have stereotypes, right? So if there are stereotypes, we'll have a color. The color will be r dot, whatever that is, properties. And then we could just say, please output the color. Nope, no end lines, that's fine. Okay. So let's just see what this does. I'm not entirely sure where we are. Oh, there we are. Okay, so so the good news is we seem to have some kind of stereotypes available. Spacing seems to be an issue. This guy should have his own space, really. But what was not entirely successful is we didn't really seem to have any colors. So peculiar, actually. We should have at least had the default color. Oh, sorry, there's a slight problem here, of course. This was actually not very good thinking at all. Yeah, we're returning a whole lot of colors. That was very, very schoolboy error. Okay, that is not going to work. We're so concentrated in the macros that we forgot the actual purpose of the code. So this guy here needs to return a color. Yeah, sorry, after all that work, I think we need to throw all this away. We need something more like if, then else. Yeah, sorry, we were far too focused on the task at hand. And let's try another macro then. So something more like if nope, this is not gonna work, sorry. Let's try again. So we need all of these guys here. Right, so let's try again. So something more like if, and then look for the comma, close, turn string. Right, so now this is not going to be, oops. Right, so we've done something very bad in our macro. Macros do require a bit of practice because every so often you put some commands in the macro, they're not very reproducible. And then those commands cause all sorts of problems. Let's try again. So we want, okay, I think the problem is let's just make sure we didn't do any more copying and pasting inside of the macro. It's very easy to do it without noticing you're doing it. That seems alright. Okay. Right, so yeah, apologies for that, not thinking straight there. This should hopefully do what we wanted to do in the first place. Not exactly the most beautiful code, but to be fair, we just needed to do basic task. Okay, well, I guess we could probably add a few else's here. We will make this code a little bit better, just not at the first go. As usual, we just go for the easiest possible way. Right, we need something that gives us... Oh, okay, that's actually not too bad. However, we could do it as space. But we know for sure there was some kind of stereotype. Okay, that's an interesting point there. We relied on the presence of a default stereotype. So, that being the case, let's not worry so much about whether we have stereotypes or not. So we don't know if there's going to be something in front of us. So right, so this now should give us something a bit more sensible. Okay, so this is one annoying thing about PlantUML, is it seems to just fairly randomly choose where to place his output. Right, so as you can see here, this is now generating something more like it. Although, to be fair, these colors don't look like our colors. So, handcrafted tappable. Oh, okay, I think the problem there is that we didn't really give it a complete table of colors. Sadly. There's a second palette called the Dogen palette, which is this guy here. We didn't really go through this one. Let's just do it now. So for this guy, to be honest, we don't really particularly care about that right now. Right, so for this guy, what color do we need? Triple F ACD. So let's just do these guys here. Actually, to be fair, we probably should rely on the script we had, which I think we deleted since. Let's just see what happens if we go perhaps all the way to the previous sprint. And if I'm not wrong, where would colors be? Maybe inside a dia? There used to be some Lisp. Okay, not inside of dia. Ah, actually, sorry. What I really meant to do is not the previous sprint, but the one before that. So let's go back to releases. And if we just jump to this guy, and then projects dia. Oh, not that. Right, so there was some, well, I thought this, but what I really meant was Python. There was some Python code to color things. Not just sure if this is any easier, really. So, where is the Dogen manually generated palette? So 0, 1, 2. Right. Oh, well, 0, 1, 2. Maybe these three guys here. There's not quite. Oops. So that doesn't quite look like the colors we're seeing in the screen at the moment. But hey, we just need some colors. We can always adjust the colors later. And yeah, these colors are quite different from the ones you see in the screen, but it doesn't really matter. We just need some kind of colors. Can always change these later. So let's say we start with these colors, whatever they are. And for the purposes of this exercise, we will just take these guys here. And do something like oops. We're having a lot of problems at the moment typing some reason. Either me or Emacs is misbehaving. I suspect it's me. Right, so first guy. Of course, this is just a very really simplistic approach for this. As you can imagine, this is not really going to be very scalable. We just need something to come out. But once we're done, once we have time to do this properly, the right thing will be, of course, to make sure that we have some kind of table that's actually user defined, that maps stereotypes to colors, and then we just consult the table, really. But of course, that's not what we're gonna. We never start with a complicated version. We always start with some kind of really trivial hack, because we find that a lot of times, almost all the times, the thing that we think is obvious is actually ends up not being obvious at all. There's all sorts of problems with the approach, and if you spend a lot of time trying to make it perfect before you know about these problems, you then end up having to rewrite a whole lot of work, because you will find inevitably that what looked great in this sort of not design, but in theory, is actually not the ideal at all in practice. So that's why you see all this hackery, sort of the fruit of experience. And it was painful, the experience, to be fair, but I guess you need some kind of way to learn these lessons. Right, now then, after all this copying and pasting, now you may think, why were you spending so much time trying to create some kind of PlantUML output? But the problem is, we are quite used to dia. We are extremely used to dia, and because of that, it's a bit of a problem not having any UI at all. Okay. I'm actually gonna revert back to the yellowish tones, FFFACD. Let's just go for that. I want to see quite obviously which types are generated by hand and which ones are not. So we'll start by making these guys some kind of variation of the, I don't know, DD perhaps, and DE or something, I don't know, it doesn't really matter. That should have worked. Right, so let's go back to this guy here. Just needs, okay, right, it's preferable really, because now you can quite clearly see that the yellow types are types that were handcrafted versus the ones that were not handcrafted, which is a good thing. Let's just look at this in its full size. Not too bad. Okay, so that's a good start, I should think. So now then, let's try something a little bit more complicated then. So we have the class. Where is that example again? Now we need to add some fields. So these fields will just be quite straightforward really. And we're doing for time. An hour and 10, oh wow, time's flying. Let's just get something basic going, and then so if I just say something like well, we're just gonna have a default indentation of, I don't know, whatever the sample has. Quite a lot, funnily enough, but okay, whatever. If Emacs thinks that's a sensible indentation, who are we to argue? And then we say something like field, and then something such as attr dot name, perhaps, space, and then something such as attr dot, well, what would be sensible? Attr dot type, perhaps. LSP seems very lazy today. Type. Now what we'll do is just make our life a little bit easier. We'll just break this into a few lines. And something like this, I guess. Oh, sorry, not simple. Oh. Right, so there are cases where we don't seem to have a value. Which is fair enough, enumerations is the one. Okay, so let's row back one and say if keep forgetting to do a not when I know exactly it's going to be a not, but there you are. And in this case we would like a space, and that would do it. Oh. Righty, so we forgot perhaps some end line somewhere. Okay, not too bad. don't seem to have any fields with values, which is a bit surprising. In fact, it's extremely surprising. This is a bug. What else is there in an attribute? Oh, keep forgetting there is no more dia. It's going to take quite a few years to get used to it. Yeah, it's been quite a while. So let's just say we have a Dogen model and we are looking at... Oh yes, I remember now. Okay. What's happening at the moment is that the value is stored in an attribute. It really depends how the value is being carried. And I think it is actually via metadata. So we just need to make our guy a little bit clever. Rar. And extract something else. So type tag, not quite gag. Right, so that seems sensible. And we could then say that if you do find one of those chaps, make sure we're not being talked to. Quite a lot of noise going on outside for some reason. Just a quick check of what's going on in the world. Not much. So, as you can imagine here, we just need to do exactly the same. So if the tag is the type tag, just remember the type. Now, this is really not ideal, as you can imagine. I mean, we're doing quite a lot of hackery, to be honest, but we will at some point fix this. This guy has got the properties. And what we need to do is to say, oh, of course, these are now part of the attributes. So let's just do exactly the same thing in the attributes. Let's extract the properties. And then we could just say if the type is not empty. Really, we should check for both, but as we're going to be lazy for the moment, what we should recheck is to see where the type is being conveyed, because it could be via the attributes or it could be via the stereotype. But okay, we seem to have classic copy and paste error. Okay, and there you are. Something approaching a set of classes. Let's look at this in a bigger view. Okay, it's not too bad. Now, as you can see here, we can tell whether it's an enumeration, a class, or something else. So we could probably make use of that. Interesting, this handcrafted. Oh, presumably one of them takes over the precedence over the others. There's something else we need to look into. Right, so a couple of things really. We could categorize exceptions and enumerations differently. That sounds sensible. Also, we are not taking into account namespaces, so how would we do that? let's try to generate a model that has namespaces on it. Oh, another thing is we didn't, sorry, let's just go back by one. Right, what we wanted to do was we wanted to add a note. Let's look at the PlantUML spec again. Oops, not you, but notes. Notes and stereotypes. Right, so here's a floating note. Right, let's just try to add a floating note. One slight problem is, I wonder if there's a simple way to say multi-line. Okay, wow. You can make some very complicated notes, so let's try to do one of these. So if we do something like if the model dot comment documentation, one of these two. So if the documentation exists, let's just say, oh, interesting. Do we need to have a name for the note? So if we just say note as right, I'm not entirely sure exactly how notes work, but I will just start off by hard coding this note to be an N1 and then we'll see what happens. And then we seem to require some kind of spacing, so we'll do headline, and then we will just go for our ident. So if I just locate wherever we put that massive indent. Probably should stop being lazy and create a constant for this. And we can replace this chap. Right, so we have something like an indent, and then we could just say a bit of indentation here. Although to be fair, actually I'm not going to put indentation here because we'd have to break the notes into lines, and there would be just a lot of complications. So let's just see what happens if we just do m.documentation. It's just not going to be and then we could just end the note. Righty, so now then, this note, if I just look at our plant source, okay, so that is the note, and I think we are good to go. Let's try something a bit more complicated then. It is a shame that we can't very easily create relationships between types, because we'd have to start processing the types, and that would not be so easy. Right, so we have to worry about classes, enumerations, interfaces, and packages, I guess, in terms of types. So what do we need to check? We could probably check the fallback. Well, actually, before anything else, what happens if we try to generate a model with namespaces? Let's just see how bad this would be. So let's look at something like CLI. No, too simple. Codec, probably too complicated. The org mode model. Oops. This copy and paste from Diet seems to be a bit creative. Right, we are running out of time really, because this is supposed to be a quick video, and okay, the usual, nothing to do. Let's just run it again. Right, let's see. Aha, interesting. So we did not create namespaces, but interestingly enough, the types are correct. And then, as you can see here, there's this entities chap here, and that is the namespace coming through not quite right. So we need to figure out what this thing should be. Let's just say that our properties, let's just create a very simple enum here. Enum class type. This could be an enumeration, an interface, well, let's just call this UML something, because otherwise we can't call class. What else could it be? Package. Not sure what else we have. So declaring an element. Right, so here we are. So there we are. So there's abstract, annotation, class, entity. Oh, I like entity. Interface. So right, we're gonna have to make use of some of these guys later, but for now, let's just make use of a few of these guys. So entity, I quite like entity actually, because entity for code-generated code. But of course, there's not all code-generated code is entity, so it could be an enumeration as well. But the idea of an entity, though, to be fair, let's not worry about that later, right? So what we really need is class, enum, and package or namespace. Right, so there is this notion of a set namespace separator. Okay, fine. So where have we got then? We are enumeration and well, we don't really have interfaces yet, so let's not worry about that. Let's worry about this tree. We already have type, so let's just say element type perhaps. And then here we could just say element attribute. Something like this. And then we could just say that this guy here has an element type. And finally, we could determine the element type as we extract the properties. So now this is going to be a slightly more complicated thing. So to determine the element type, we need a few things. So the first thing we need perhaps is a bool found enumeration, which is false. And then we could just create a simple tag here. No, actually we already got it. So if tag is enumeration, found enumeration is true, we're not really going to bother with checking whether there's logic to this. And I mean, of course you can imagine we could have all sorts of invalid permutations here. It's not quite the time for all those checks. So now we could say something like, so if found enumeration r dot element type is equal to UML enumeration. To be fair, actually, instead of attribute, what we need is something like none. Just purely so that we could start with none. So if you find enumeration, we could just say that we are element type UML enumeration. Then else, if one slight problem. Yes, we have a slight problem here because the rest of the information is not here. What we should really do instead, actually, sorry, just as I did all of this, let's just say something instead like this: bool is enumeration. Now this may sound a bit weird, but actually in reality we only have one thing that we're going to check for, which is enumeration. The rest is checked elsewhere, so we'll just do a slightly, well, still a hack, but different kind of hack, I guess. Right, so then what we want to do is something like this: to determine whether you're a class or not, which we just assumed a second ago. So what we're going to do now is we're going to process the properties, and then do something like this. If you're an enumeration, not sure why. If you're an enumeration, well, there's not much you can do really. We are just going to output whatever that guy said. Enum. Okay. Else e dot fallback element type is equal to MASD package. I don't think we. Now I wonder what the fallback element type is. Module, I guess. Right, so we just need an additional type here. So if you're a module, we would like to call you a namespace, else if. And if you don't really know what to call you, we'll just call you a class. And then we'll just give you a name. So let's see what this does. Shouldn't make any difference to this guy. But we expect the other guy. Oh yeah, it's this guy. Okay, so we don't seem to have a namespace here. Interesting. So there is the belief. I wonder if yet again we are not having another problem. Right, so there is no fallback element type here. Yeah, so we just found a bug, I think. The bug is org mode elements are not populating the fallback element type. Okay. Not sure why they wouldn't, to be honest. Let's have a look. Org artifact to model. So let's look at module. Yeah, so that's popular. Oh, sorry, you're in the wrong place, right? Org artifact to. Okay, yeah, that's good. That's good. And then yeah, area fallback element type module type. Now I would like to think that this is MASD module, and I would like to think that this is MASD module. So that makes me think that something has gone quite wrong here. So we don't think the fallback element type is being populated, but it should really. What happened to enumerations though? Did that make it any better? I don't see any E's. No. And I can clearly see here that this is an enumeration, so that should have worked. So it seems to me, okay, let's just double check we're doing the right thing. So, we are running this against the wrong model. Okay. Right, see a few E's now, so that's good. Still, in fact, a lot of E's now. In fact, a bit too many E's. Pretty much everything is an E. Okay, the problem may be that we are probably not setting. Yes, there is no construction. So this is a classic case where one should always be careful with C++. We were relying on the fact that the things that we had on that class were all sensible things and had constructors. But then we added a property that does not have a constructor, meaning suddenly we started doing the wrong thing. Right, let's try again. Right, now then, we gained more classes, but we lost all of our enumerations again. Okay, we got namespaces, so I guess that's positive. Are we looking at the right model? Yes, that's an enumeration. Okay, cool. So that's not being detected. fine. Let's try one more time. Oh, the other thing as well is we need the automatic namespaces really. It's not really getting us there. So let's just say right, as you can imagine, we're not actually we're not going to get the absolute best UML in the world. We just need some kind of UI. Right, so let's try again to look at our org UML. Okay, so as you can see here, this has already been an improvement. We now have something like a namespace with some kind of color. And we have the transforms in one place and then the helpers in another. It's actually looking half decent, just missing really the enumerations. So let's now try to understand why on earth the enumerations are so hard. So we are just checking to see if we're in enumeration after reading the properties. So we check to see, okay, now I see why. The problem is we are really checking for the absolute wrong thing. So really what we're trying to do is, so geez, okay, right, so clearly we are really not concentrating at the moment, so let's just start all over again. This was a very bad schoolboy error. So what we're trying to say is, we're trying to say, first locate the stereotypes, and if the stereotypes contains the enumeration, then we are in enumeration. Right, okay, that should help. Let's have a look at the diagram then. Okay, so, right, not the most beautiful diagram in the world, but it does give you a graphical view of the model. You can see, interesting that there's a lot of things here that are exactly the same color as the namespace, which is not ideal. But you can see the classes, the primitives, stereotypes, all the properties, whether something is in enumeration or not. And that's actually not looking too bad, I think. Oh, there's one that we didn't do, untestable. That should really be quite red. So let's just go and grab yet another stereotype. Don't know why, but I always prefer to put the open brackets to the other side. So untestable. Can't quite remember what color we chose for untestable, but it was fairly red. We could perhaps jump over to frozen and have a quick look at models, dia, and then in here the org mod model perhaps. Yeah, there we go. And that is F-E-E-7E7. And we should have copied, of course, the string. Right, so 7E7, I believe. Right, so we want to keep an eye on anything that's marked as untestable because we can't generate the tests for it. That's why it should be very red. I mean, we're going to find lots of problems as we go along, as you can imagine, but we're just trying to get the basics. Okay, we seem to be on the wrong model. Where is our untestable? Ah, there we are. Not that red, to be honest. Looks a bit redder in dia. Let's look for a color that's actually more obviously red. Just to make sure it's very visible. The other problem really is that the color of the namespaces really is not helpful. I actually wonder if the problem is that we never did add a color to a namespace. Yes, that is the problem. The default color of the namespace should have been something else. F2, F2, F2. So now we have to be careful here. So where are we then? Wow, this video is getting really long, almost 2 hours. So let's just see where we detect the namespace, which is here. Still do the stereotypes, then we determine the color. Now I think what we should do is yet another hack. If we're a namespace, do something else, do something else. And in here we will do our usual whatever it was, F2, F2, F2. Right, so we want to make sure the namespaces are really not similar to anything else. As you can imagine. Okay, we are very much red now. And yeah, as you can see, the namespaces are now grey, so that's good. Okay, so I think as a very basic way of generating diagrams, we seem to have succeeded. Let's try something a bit more complicated. Let's try the logic model. The logical model. I keep calling it logic model. So this will be logical. Oh. Usual. Okay. This will be a very large model, as you can see. It's giving some trepidation to PlantUML, I think. Still thinking. Might not be wise to generate such large. Oh wow, it did work. I think Emacs is not going to be terribly happy though. Let's have a look. I think we managed to find the limits of Emacs. these kind of large models. I think we should probably just try to close it. And let's open up with the graphical editor, I think. Right, there we are. I'm just gonna find this PlantUML buffer. Preview buffer. Oh, it's an SVG as well, so you can imagine that's probably requiring a lot of rendering. Okay, so we have a shell somewhere. Yeah, that would do. Let's rename that to become the shell for PlantUML. Now I haven't actually used PlantUML in the shell before, so Dogen logical. I mean, my completion in the shell is atrocious at the moment. Oh, wow, we're in the wrong place. So projects, Dogen models. Oh, org. Okay. It will take some time. Now I'm not sure what kind of types of files it generates. PNGs, okay. Well, we might actually be able to open a PNG, hopefully. Oh, okay. Right, so it did something. What's the easiest way to open up a PNG these days? Photos. Okay, shot well. Let's attempt to open up this PNG. Oh, import from folder. No, this looks a bit too complicated. Must have a file somewhere. Right, there we are. So, files. Let's open up a new window of this. And return to our dial would do. So, if we just go up to whatever. Wherever we were. The guts of Dogen and have a quick look. Should have a model somewhere. Right, let's have a look then. So there's some good news and bad news. The good news is that we seem to have generated a PNG that's vaguely correct. The bad news is that the sub namespaces didn't really get populated correctly. Not clear why that would be. They seem to have lost all the types on the sub namespaces. Let's have a quick look. This probably is a very easy thing to fix. So let's choose something like, I don't know, say objects, for example. Oh, actually, one thing we did not check as well is, did concepts come through object templates? Yeah, they did come through. They have a color. I would say this color looks rather suspiciously like the other colors, so we definitely need to make some work on the palettes, I think. But what we really want to know is, if I look for structural, I guess. Right, as you can see here, we definitely have the entities coming through inside of the right namespaces, so not clear why they're not coming through in the diagram. Right, okay, so this is already taking about 2 hours, so let's just not go too far on this, but you can see the gist of it. We just have to faff around a little bit more with PlantUML to get this to do the right thing. But this would certainly be a good replacement for our use of dia, because A, we don't have to worry about anything, we just generate it and it comes out, and B, once we got the right format anyway, and it's very quick, which is good. We can be able to configure the colors quite easily, and that means that we got some kind of way of visualizing what's going on without having to rely purely on org mode. So that will be very helpful. We just need to solve the small problems that are still left. But all in all, you can see it worked okay. I mean, the bit that we were supposed to really be demonstrating in this video was actually quite straightforward. All we did was the one very tiny change to this model, which we've already committed, and that wasn't even this model, it was the Codec model, and we added a new transform, and as you can see, it was very simple. We just have to locate the right namespace. In this particular case, transforms, and in that namespace we just need to add the transform there with whatever properties you'd like, and away you go. That's it. It's very, very simple. We can copy and paste, we can insert using any max functionality we already have, and then if we want to visualize it, you could also visualize it. It just requires a little bit of fiddling with the visualization, but we're getting quite close, I think. So that is it. That is all for this series. As you can see, we now support org modes as our first class citizen, as we expected or wanted to do, and it seems to be working okay. So I think we're happy with this. Okay, that's all for this series. Thanks very much for watching.